Okay, I was going to go over a weekly quiz. I was going to go over weekly quiz 6. So it says click and drag like terms onto each other to simplify. And so literally what you have to do is click on the term. Remember, a term is anything separated by a plus or minus sign. So we've got 5 terms here to combine. You can only combine the ones that are like terms. So if I try to drag 7y with negative 2, for instance, it would come up and say the terms are not like terms. They must have the same exponent to be combined. In this case, they must have the same variable to be combined. Exponent is something that you'll see next year, actually, when we start combining that as ninth graders in algebra. So I have 7y and negative 2y. I can combine those. So I'm going to drag that over. And if I've got a negative and a positive, it looks like I have more positives, so it'll be positive. And I have the difference between 7 and 2 is 5, so I have 5 more positives. Now, watch what happens if I hit 5. It's not going to let me get away with that. Remember, 7y minus 2y is going to be 5y, and so then it will let me have that, and now I've just simplified it. And I'm not able to submit it still, and the reason for that is there's more simplifying to do. So 5 and negative 2, since they're both constants, they're both numbers, they can be combined. And negative 2 plus 5 is positive 3. There's more positives than negatives. And then the last step would be, I've got 3 minus 1 here, so I can drag that over to negative 1. And that will equal positive 2. And so it says you've successfully combined all like terms, and then I can submit answer, and we are good to go. And it gives me kind of a breakdown of what I just did. So in case you get it wrong, you can look at that and see what the mistake was. This one right here looks like it's a little bit more complicated. So what I'm going to do is I'm going to do the workout off to the side here. And in your notebooks, what we expect from you is for you to show your work on a problem like this, because I don't think I could solve this in my head. And I've been teaching math for a couple of years now. So it says solve the following equation for x, and then make sure you express it in simplest form. So if I've got that, let's see. The first thing I would start with is distributing. So negative 6 times negative 5x. It's a negative times a negative, so that'll equal a positive. So it's 30x. And we're also going to distribute negative 6 to negative 1. That equals a positive as well. So now I've got 30x plus 6 is the same as 5x plus 20. So I want to put all my variable terms on one side. I want to put all my constant terms on one side. And it doesn't matter where I start. Like, I could start by subtracting 30x. I could start by subtracting 6. And the reason I'm subtracting is that these are both positive. Or I could start by subtracting 5x or subtracting 20. It really won't make a difference. For me personally, I like keeping numbers positive where I can. So like if I was to subtract by 30x here, I would have to subtract by 30x here, and then I'd be doing 5 minus 30, so I'm getting a negative. It's just my preference. I don't know. I've always found positive numbers to be a little bit easier for me to do. That's what you grow up doing in elementary school, and it's generally what you use more in real life. So I'm going to start by subtracting 5x here. And that way, when I do it on the other side, it's 30 minus 5, and it comes out to a positive answer. Now, I won't always be able to do it that way. And, you know, we're in position where we've learned enough about positives and negatives where it should be possible. Whoops, that was my lesson that I just created for my other class. So now I've got 25x plus 6 is the same as 20. Our goal is to get rid of the numbers that aren't x. We're trying to find x. And this is an instance, by the way, where there's going to be one solution because there's nothing to cancel out that 25x on the other side. So we'll say, let's see, 25x equals 14, which looks weird because these are numbers that you're not used to. Like, I'm going to divide right here. This is, by the way, is going to be my answer. X equals 14/25. You're probably not used to getting fractions, but, you know, this can happen. Fractions are numbers too. So we get 14/25. So I would say it does have one solution, and that solution is 14 over 25. And we can say, yep, that's the truth. And now they're going to tell me I'm right. Okay. And they detail, every step. So if you get it wrong, the nice thing is you can see kind of why it's wrong. Right here it says 5x plus 2 equals something minus 4. We're going to complete the sentence. So the equation will have one solution when h equals, and they make you think. But the main thing is that the coefficients have to be different if you're going to get one solution. So it doesn't really matter what I put here. As long as I don't write that number, as long as I don't write 5, I'll be okay. So let me just write 4. Because you get one solution when you have a different number of x's on either side of the equation, and constants, they won't really matter. You'll get a solution either way. They could cancel each other out in that case. Like if it was 5x equals 5x, I'm just a bad example, 5x equals 4x, that really means 5 times something equals 4 times something. So in that case, it would have to be 0. 5 times 0 equals 4 times 0. And your constants would just both be zeros. Let's submit that. All right, so they give you a nice chart here. So if it's 0 solutions, that means that the coefficients are the same. So they say the same number of x's. And the constants are different. If it's infinite solutions, it's the same number of x's. And the constants are exactly the same. It means it's the same expression on each side of the equal sign. And then the one I just did was one solution. And that's the only thing that matters there, is that the x's are different. The coefficients are different. And the constants, it really won't make a difference at that point. Try the next problem here. Distributive property. We multiply 8 by everything inside. Okay, we're going to try the next one. And you can see it's another equation. I can already tell if I multiply 4 here, I want you guys to do this out, but I'm going to get 24x. So you've got the same number of x's, the same coefficient, so it's automatically not one solution. It's either infinite or none, and I would say in this case, because 4 times negative 8 is going to be negative 32, it's infinite. We have the same number on both sides of the equal sign. Hopefully that helps you. If you need any help, send me a note.